Hey, Advanced Math, this is Mrs. Harbin here. Welcome to Unit 1, Lesson 1, Real Number Operations. Our biblical correlation comes from 1 Corinthians 3, 9 through 11. For we are God's fellow workers. You are God's field, God's building. By the grace God has given me, I laid a foundation as an expert builder, and someone else is building on it. But each one should be careful how he builds, for no one can lay any foundation other than the one already laid, which is Jesus Christ. We know in building and in reading and in math and in life, we've got to have a firm foundation. And the same is true in math. Like I just said, we've got to make sure we know the basics and have a firm foundation before we can move on to more advanced and complicated tasks. So let's start off with some of those basics. Our lesson objective is this. The student, you, will be able to find the absolute value of a real number and evaluate numerical expressions using the order of operations. Now, we have some basic arithmetic operations that you need to be familiar with. You should know these. If not, don't worry, I'll get you caught up. But in addition, we have two addends. Put those together, you have a sum. In subtraction, you start with a minuend, you have a subtrahend, that's the part you're taking away, and that leaves you with the difference. Multiplication, we have factor times a factor equals a product. In division, we have a dividend divided into a group, or a divisor, and we're left with the quotient. And then exponentiation, you have a base being raised to an exponent, which is just really a factor. This is your factor. The base is your factor. Let me try to write on the screen here. The base is your factor, and the exponent is how many times you're multiplying that factor. So 2 to the third power, for example. We use a factor of 2, and we multiply it 3 times. So that looks like 2 times 2 times 2. Now, this is just a reminder of things you should have learned before. Don't stress over the names, but you can always come back to this chart as a reference. The absolute value of a number, which is represented by these absolute value bars, x is just representing any number, is the number of units or the distance between 0 and the number's graph on a number line. So it's basically how far away it is from 0. The absolute value is always positive, or it's 0. Because we're measuring distance, we're measuring that in positive terms. Let's take a look at an example really quickly. So let's say we have a number line. Sorry, it's not very straight, and we've got a 0 here. And we've got the number 1, 2, 3, 4, 5, 6, 7, 8. Okay. The distance between 0 and that digit on the number line is 8. Well, that's what we come this way. 1, 2, 3, 4, 5, 6, 7, 8 to -8. Well, if we look at the distance between -8 and 0 on the number line, it is also 8. So both 8 and -8 are 8 spots or 8 places away from 0 on a number line. They both have an absolute value of 8. Order of operations. As a reminder, we are using PEMDAS, or maybe even you want to say GEMDAS. That G stands for grouping symbols, which can include parentheses, brackets, and absolute value bars. E stands for exponents. M and D, multiplication and division, we do those at the same time, from left to right. And addition and subtraction, we do those at the same time, from left to right. Now, order of operations, PEMDAS, GEMDAS, wasn't really standardized in textbooks until the 1970s. So if your parents or grandparents are trying to help you with math and they didn't learn it this way, it could be because it wasn't standardized. In fact, I think when I learned order of operations, I learned it a little bit differently as well. But this is what has been standardized now, and this is what we will be using. So we've got our grouping symbols. First, parentheses, which we've said are parentheses or brackets or absolute value bars, or even a radical sign acts like a grouping symbol as well. Followed by our exponents. Remember, exponents was just a base, so a factor, and how many times we're multiplying that factor. So that's 2 times 2 times 2 in this case. So don't forget about those exponents. We do multiplication and division at the same time from left to right, and addition and subtraction at the same time, left to right. It is really important that you follow this order of operations to make sure that you are getting the correct answer. You are getting a correct and useful answer. All right, so let's take a look. We want to simplify this term, and we're going to do that by order of operations. We have 2 plus 4 times 3. A lot of times that dot is used for multiplication, so it doesn't get confused with an x. Using our order of operations, we don't have any parentheses or exponents, but we have some multiplication. 4 times 3 is 12. That leaves us with 2 plus 12. And according to our order of operations, we can now add and subtract, which gets us to 14. And take a look at this one. We have negative 2 squared plus 1 minus 3 to the 4th power minus 2 times 4 minus 3. Now we do have several things in parentheses or grouping symbols first, so let's take care of those. 1 minus 3 simplifies down to negative 2 here, and 4 minus 3 simplifies down to 1 here. The next thing that we have is exponents, so let's take a look at our exponents. Now notice that this is not negative 2 squared. If that were in parentheses, we would take that whole negative 2 and we would square it. But what it says is just the negative of 2 squared. 2 squared is 4, so we have negative 4. Here we do have, in parentheses, negative 2 being raised to a power, and negative 2 times itself 4 times is a positive 16 here. And then no other exponents. Next we have multiplication and division from left to right, and we've got one multiplication problem here, so let's take care of that. Negative 4 plus 16 minus 2 times 1, which is 2. And then we have addition and subtraction from left to right, which gets us to 10. Here's one. Why don't you pause the video, see if you can do that on your own. We've got our grouping symbols first. So 2 minus 8 is negative 6, but we've got an absolute value bar there. So this just becomes positive 6. Our minus sign stays the same. We don't mess with that, and that leaves us with 3 minus 6, which is negative 3. Check your work, see if you did it right. An algebraic expression is a constant, that's a number, a variable, usually x or y or some other letter, or a combination of these symbols and operations signs that is used to represent a number. For example, we could have 4a, that's a constant in a number, or 3a squared b. That's an algebraic expression as well. We have a constant, a variable, and operation signs. We've got the exponent sign in there. When we talk about the substitution property of equality, we're looking at this phrase, if you will. If A equals B, then A can replace B in any expression to produce an equivalent expression. Think about it in terms of keys, house keys. If my house key, the A key, is the same as Mr. Harbin's house key, the B key, then I can use either key in the door, either my key or his key, because they are equivalent. Keep that in mind when we start working with equations. To evaluate an algebraic expression containing variables, remember those are the letters like x or y, substitute the value for each variable into the equation and simplify. Or, as Mr. Rocky, my math teacher, always said, plug in those numbers and chug out the math. Plug and chug. So we're going to evaluate. Or, again, plug and chug. Evaluate when x equals 2, y equals negative 3, and z equals 1/4. So here's our original expression. It has all variables, but just like my house key is the same as Mr. Harbin's house key, we're told that these variables actually do have number values. So every time we see x equals an x, we're going to plug in a 2. Make sure when you substitute that you use parentheses. So whenever I see an X, I'm going to change it to a 2. And I'm going to keep that in parentheses. That square symbol's still there, so it goes out here. Yeah, I'm going to put my Y in parentheses, but I'm going to substitute a -3. It says that Y is equal to -3 up here at the top. And then finally, I'm going to minus, and then I'm going to put my Z in parentheses. And according to my substitutions up here, Z is equal to 1/4. It's really important when you make substitutions that you use parentheses. You may be able to get away with it right now without using parentheses, but later on down the road, you're going to need those parentheses. So let's make sure we start good habits. Right? It's a little hard to see with my handwriting over the top of it, so let's go ahead and erase all this handwriting that I have so you can see there. Notice that parentheses were used there as well. Again, get in the habit of using parentheses when you substitute. Using our order of operations, we simplify 2 squared to 4. We're adding a -3, which is just subtracting 3, and then subtracting 1/4. We have 1 minus 1/4. Now we know when we add and subtract fractions, we have to have a common denominator. 1 is just the same as 4/4. And when we're adding and subtracting fractions, we're really only looking at the numerator. The bottom number, our denominator, stays the same. It tells us the size of our fractional pieces. The size of the pieces don't change. How many pieces, this top number, is what changes. So we're left with 3/4. All right, try evaluating this expression on your own. Pause the video here for a few seconds, see if you can do it, and then watch the steps. All right, we're going to plug in our values. We really should have parentheses here because we're plugging in that 2, and we really should have parentheses here. We want to use parentheses every time we do a substitution. We're then going to use our grouping symbols, exponents, multiplication, division, addition, and subtraction in that order. We don't have anything inside the grouping symbols we need to simplify, but we do have some exponents. 2 squared simplifies to 4, and -3 squared simplifies to 9. Again, this subtraction sign does not get changed. We're going to leave it there. 2 times 1/4 becomes 1/2. If you've forgotten how to multiply fractions, 2 is just 2 over 1. 1/4, we're going to write like this. And when you're multiplying fractions, because you're not combining, you're just making groups, you don't have to worry about the denominator. We just multiply straight across. 2 times 1 is 2. 1 times 4 is 4. And 2/4 is the same as 1/2 once reduced. So that's what's on the bottom of that fraction there. We then have 4 minus 9, which gives us -5. And -5 divided by 1/2 is the same thing as 5 times the reciprocal, or -5 times 2, which gets us 2. That should say -10 as our final answer. -5 times 2, -10. All right, try this one on your own. And then follow the steps to see if you were able to solve it using your grouping, your exponents, your order of operations. You ended up with -1. If you have questions about that one, make sure to see me next class. Example number 4. Again, try it on your own. Pause it right here. See what you can do. Notice that we did use parentheses every single time we made a substitution, even inside those brackets. It's really important to use parentheses when you make substitutions. We end up with some fractions here, so we're going to have to find a common denominator. And our common denominator is 16. Changing everything into fractional form, we end up with 19/16, which cannot be reduced. We can also use algebraic expressions to convert between different kinds or types of measurements, like Celsius to Fahrenheit. Using this formula, Fahrenheit equals 9/5 Celsius plus 32. You can plug in that 15 degrees Celsius into the C spot, do a little math, and you end up with Fahrenheit is 59 degrees, especially useful if you're traveling out of the United States. Or we can use this formula for Celsius and work our way backwards to find Celsius.